So my name's Danny. Mariah didn't give me any kind of an introduction. I would have really liked to have heard what she would have made up. I'm a solutions architect at Qubole. That means that I go with salespeople like Brandon, and when they don't know what they're talking about anymore, I start talking for them.
Usually the other way around.
With Brandon, it's sometimes the other way around because he's the most technical salesperson I've ever worked with in my life. I'm going to talk a little bit about Qubole later on in this presentation, but I'm going to try really to focus on the state of the industry, theory and foundation, and talking about this thing that is really, really relevant and really important to data science, but that you will not hear anybody talk about in any classroom in any university, because it is entirely application and practical based and so completely removed from what we studied in academia. So the process of deploying or productionizing machine learning models is really about taking this thing that data scientists spend so much time working on and then actually making it useful, actually creating a business impact with this machine learning model. Because otherwise, data scientists are just being scientists, right? They're coming up with these things that never get actually applied within the industry, never actually get applied within an application, and never actually benefit the business that they're working for. So this process of productionizing or deploying, I'm going to use those terms interchangeably, is a really, really important step in the process of making machine learning models useful. But let's understand how it fits in with the larger picture of the machine learning workflow. So all the way on the left here, we have the exploration and preparation of the data. Really, even before this step happens, there's some more hand-wavy nebulous stuff like figure out what question you want to ask, find your data. But once you've got your question and your data, the first things that you're going to do are explore it, right? Do some EDA, maybe using data visualizations, trying to understand the relationships between your variables, how the independent variables fit together, as well as how they're correlated with the dependent variable. And then you're going to be preparing the data, right? So you're going to be doing some feature engineering, some feature selection, maybe normalization and standardization. You're going to be getting the data ready so that you can do the cool, sexy thing that everybody's always talking about, which is building the machine learning models. So this is where you'll hear the majority of data scientists, especially the people who talk about data science without doing data science, they're the ones that spend all of their time talking about this, because they talk about comparing different types of models against each other. They talk about these like really incremental minor improvements that different model types will create. And to be fair, you know, there is value in the creation of new model types and the comparison between them. But at the end of the day, the data scientist spends 80% of their time on this first step, the exploration and preparation, and very little on the building and validation of machine learning models. But once you've finally selected your machine learning model, the final step, the one that gets completely ignored, is the deployment and the monitoring piece. Really, this conversation about deployment and productionization of machine learning models has only come around in the last few years, because that's the only time that the industry is finally matured enough as a whole to be able to have conversations. And we still don't even really have a language in order to discuss these things. Like, I'm going to use some words that we coined at Qubole internally because nobody else was describing these concepts externally. And I think that's going to be what's talked about at the meetup tomorrow night at Recursion. So the final step of the process is once you've built your machine learning model, you need to be able to deploy it, right? You need to integrate it with your application, actually make it useful, and then you need to be able to monitor it, right? You need to make sure that it's still up and running, just to start with, that it's still being performant in terms of the amount of time that it takes to run, that it's meeting the SLAs that it needs in order to make your application run sufficiently quickly, and also that you're not seeing a decrease in the accuracy as the data structure fundamentally changes over time, right? We have trends in our data that are going to be changing over time, and if we're not updating our model to go with those changing trends, we're going to see overall decreases in the value of our model, in the accuracy, whatever accuracy metric we use. So I'm really going to be focusing on the deployment aspect of this conversation. Obviously, all of these areas are very interesting. There's a lot of material about all of them, but in my opinion, the deployment aspect hasn't been talked about enough. So in order to understand deployment, I'm going to present to you a framework that basically separates it kind of artificially into a dichotomy. In reality, these two dichotomous ways of doing deployment really exist on somewhat of a spectrum. It's a little bit of a false dichotomy, but it's a useful framework for understanding how to do deployment. So the first one is called batch deployment. And although the diagram for it is a little bit more complicated, it's actually simpler than the other type of deployment, real-time deployment. So with batch deployment, you have data getting generated by an application. Your data is getting saved somewhere, hopefully in the cloud, because I hope all of you guys are using the cloud because it is the 21st century after all. Then a machine learning model is applied and inferencing occurs. And then as a result of the inferencing, the predictions are saved back into some data storage location to be used in the future. So this is a really like theoretical way to be talking about this. Really, those of us who have dealt with data have been doing this as long as we've been dealing with data. Like as soon as you saved some data locally as a CSV to your computer, launched RStudio and ran a linear regression against it, and then saved data back to your computer, what you were doing was batch deployment. It wasn't integrated with an application, but you were doing a batch deployment where you were inferencing against static data. In the industry, beyond people simply doing this on their computer, what we oftentimes see batch deployment be a part of is A, applications that don't have significant SLAs, service level agreements, where there's no significant detriment if your responses aren't in real time, and B, for a lot of analytics and reporting use cases. So a lot of analysts and even some data scientists and data engineers who are doing analytics work will have some kind of batch deployment model where they'll save the results back that runs overnight, where the results get saved back maybe to S3 or some other cloud storage location, and then get referenced by an executive later in the day. So that's batch deployment, pretty easy to understand. And then we have real-time deployment. So like I mentioned, this diagram's a little bit simpler, but the actual process of implementing this is a lot more complicated. And this is what I'm going to spend most of my presentation focusing on, because this is the area that we've seen some really exciting leaps and bounds recently. So for the real-time deployment, the data is generated by an application, and then instead of getting saved to a static location, it's immediately fed into a machine learning model, inferencing occurs, and then it's immediately fed back into the application. So this might be a lot more familiar to those of you who think of machine learning models in terms of their application and integration with web applications. So one really obvious example that I like to bring up is Netflix, right? So when Netflix is recommending movies for you, they don't update the movie recommendations on like an hourly or daily or weekly basis. They do it in real time. As you're watching a movie, Netflix is updating its recommendations based on whether it thinks you're enjoying that movie or not, based on your activity while you're watching the movie. The majority of web applications and other types of enterprise-grade applications that you see similarly use real-time deployment. So like Amazon, Overstock, all of these people can't wait for this batch deployment process to finish executing before they update their recommendations, their inferences, or their predictions. They need to do all of these things in real time. And in the case of such things as stock market inferencing and prediction, that real time really has SLAs that go down to microseconds because they need to be able to make those predictions faster than all of the competing firms. So real time can mean different things for different people, but at the end of the day, it's a useful way of thinking about, do I need this thing to be run on a regular basis, or do I need it to be run as soon as new data is coming in? So now that we understand this dichotomy a little bit better, let's dive into talking about real-time deployment, and then I'll circle back a little bit to batch deployment. I'm going to be showing a hands-on use case of using Qubole to deploy something in batch. But let's talk about real-time, because that's the really interesting and the really groundbreaking and exciting area that we're seeing a lot of development in today. So obviously, I showed this diagram earlier, and I just want to point out that we're going to be focusing on the deployment and monitoring piece, but really this whole process starts with building and validation, right? So the data scientist first creates a model, and under this legacy deployment model, which we at Qubole call the engineering handoff, because again, we haven't seen anybody else talking about these concepts, so we don't have any kind of common parlance to discuss it. The data scientist, after having created it, hands that model off to a data or a software engineer. That software or data engineer then has to refactor that model. That model was probably created in Python or R, maybe Scala if they're an avid Spark user, but the majority of applications are written in languages like C or Java or even Go if you're a Go fanatic like we do. And there's a good reason for that, right? Because although Python and R are really convenient languages for data scientists like me, who basically like being able to write English into our computer and leverage the computation in it, at the end of the day, the lack of A, static typing, and B, the single-threaded nature of both of these programming languages means that it's really, really inefficient to integrate directly with the majority of applications, right? So the engineer has to refactor the model. And you'll notice that there's a significant gap in this flow diagram here. right? There's a pretty big jump that occurs when that model gets handed off to the data engineer, because the data engineer is a data engineer and not a data scientist, right? This is a new human being that you're bringing in, you're handing this model off to. This person probably doesn't really understand what the model's doing in the first place. Maybe they've taken like a Coursera intro course to ML because they're curious about it, but they don't understand what aspects of the model are important, which things can be compromised on in favor of optimization of like speed performance, but might impact accuracy performance. All of these factors, the data engineer, because they don't have a data science background, fundamentally won't understand. The other issue with this is that it's a really time-consuming process, right? The data engineer needs to put on hold whatever other project they're working on. Presumably, they're not just sitting on their hands waiting for a data scientist to give them a model to productionize, right? These data engineers have other important jobs that they're doing, like setting up pipelines and doing ETL work. So now they have to put that on hold or put productionizing the model on hold. And then they have to put all this work into refactoring it, right? Which is a non-trivial process most of the time. And then they have to integrate this model with their application. All of this ends up resulting in a few bad things. So one of them, as I alluded to earlier, is that you can see decreases in your model accuracy during that handoff because the data engineer doesn't understand the model that's been given to him. Another problem is that the data engineer might not be able to do it very quickly because they need to physically go through this refactoring process, and they might be working on other things, so they might not be able to get a quick turnaround time on it due to prioritization. So the end result of that is that these models can sometimes take weeks to get productionized, which in the real world, when we need to be able to quickly A/B test models against each other using real world data, can be a really big inconvenience and can significantly damage business value of a machine learning model. Which is why we've recently seen the creation of something called endpoint deployment. And this is where Danny is going to go into story mode for a second, because this is a very personal topic to me. So about 1.5 years ago at reInvent 2017, back when I was still the data science product manager at Qubole, I went to AWS reInvent and they announced this really exciting, really cool product called SageMaker. And I was both terrified and incredibly excited about it because it looked so incredibly cool. And if you read the documentation, it seemed like the best thing in the world. AWS did that thing that they oftentimes do, where they release a product and they market it really well, and then it turns out that it's kind of actually still in beta, and they just didn't tell you that it was in beta, but it's not quite what it says it is. But regardless, there was one part that stood out to me because it was an issue that I'd been thinking about for a really long time. Real-time deployment was. It was an issue that I'd been thinking about and was like, okay, so how do I solve this problem for my customers of this endpoint deployment, of real-time deployment? And SageMaker had figured out a perfect way to do it. So with SageMaker and now with other competing services, both on other clouds as well as on Amazon's own cloud, what you can do is you can take a machine learning model and deploy it with a single click as a URL, which can then be sent a curl push with the data that you want to inference again, that you want to inference against, and it will respond with the prediction, right? This is a super cool method, and I'm going to point out to you why it's far superior to the endpoint deployment, to the legacy engineering handoff model that we had before by walking you through the process. So now, obviously, the data scientist still creates the model, but instead of having to go to the data engineer, they can simply one-click deploy the model themselves. It literally takes a single click after you've trained and containerized your model to deploy it as this URL. Then the engineer can integrate this model with their application as a microservice. I'm sure all the engineers in the room just perked up a little bit and got really excited because microservices are the thing right now. So for those of you who aren't as familiar with microservices, the cool thing about microservices is that they allow your application to be more idempotent. So if you have a point of failure in one part of the application, it won't necessarily affect all the other parts of the application. So it's nice to be able to separate out different aspects of your application. And in this case, you're separating out the machine learning model as a separate part of the application. And very importantly, both the data engineer and the data scientist can now easily monitor, right? So they can see both what is my tracking accuracy as the model has been sitting there over time. Is it still running quickly? Is it still running accurately? But then also the data scientist can quickly redeploy and can test in real time using a load balancer, A/B test, or even use a multi-arm bandit approach to figure out, have I come up with a better machine learning model and can I update the original, right? This is really, really exciting and a huge development in the industry. And what's really interesting to me personally is how much adoption we've seen of this, not just SageMaker as a product, but the endpoint deployment concept overall. Because since AWS and SageMaker came out with this, all of the other clouds have copied them and have created their own version of it. And a few startups have created their own version as well as some of the larger organizations have figured out how to do this internally without relying on an external service. So the most exciting part of this to me is the fact that we've already, among our customers, seen a 30% adoption rate within just a year and a half. 30% of our customers are using endpoint deployment and only 70% are using legacy deployment when this service was only introduced a year and a half ago. That's a really, really rapid deployment considering that some of our customers are so slow to move that they still have a ton of on-prem work going on. That's a really big deal. So this endpoint deployment was really exciting to me, and now it's been really exciting across the industry and to a lot of data scientists, where I included. So now that I've talked about SageMaker a whole bunch, and because you guys have all been enjoying this food so much, and because somebody paid for me to fly out here, I do have to talk about the company that I work for, but I'm going to do so in the context of what we've been talking about. So I work for Qubole. It's a big data platform that sits on the cloud. We enable you to do distributed computing using open source engines like Apache Hive, Spark, Presto, and we allow you to use Airflow to orchestrate. We do a lot of infrastructure management and provide a nice interface for you to work with. And the way that we deal with data science and specifically with deployment is through a few different ways. So the first one, which I'm actually going to be showing you guys a live demo of during this presentation, the first one is that you can do batch deployment really easily using Zeppelin notebooks and Apache Airflow. I'm going to be showing this to you guys. You can also do real-time deployment with the originators of it using integrations with Amazon SageMaker, Azure ML Studio, or GCP Cloud AI. And then you can also do real-time streaming deployment using the legacy handoff model using Apache Kafka and Spark structured streaming. So you've got a lot of different options with Qubole if you're developing your model in Spark with how to deploy it. And I'm going to jump into the one very, very simple and very easy and quick to explain one, which is batch deployment. So let me start off by just giving you guys a little bit of an idea of the data that we're dealing with here. So I've got this bucket in S3. It's got training data, which we're going to be using to train our machine learning model, obviously. And then we've got our quote unquote production data. So this isn't real production data. I pulled this from an open source data set on the internet. In real life, we wouldn't just have one set of production data, right? We'd be having updated production data as new data is coming in. But just for the sake of this presentation, bear with me, we just have this single production data. And then we also have this folder where we're going to be keeping our predictions, right? So we're going to feed in our production data and generate out new predictions based on that production data. So as you can see, I've run through this process a few times, but I have not done so today, right? The most recent date that this was run was April 16th, and today is the 24th. So just remember that when something magically changes about this notebook, or I'm sorry, about this bucket, it's going to be because we were doing something together today. So let me kick something off real quick, and then I'm going to run you guys through what exactly is happening. So this is the Qubole interface. We're going to be dealing with the Zeppelin notebook today. For those of you who are familiar with Jupyter, Zeppelin and Jupyter notebooks are very, very similar. If you'd like to discuss them at length later, I'm very happy to talk your ear off about it. Well, the first thing that we're going to do is we're going to dynamically define two parameters in our notebook. The first one is the production location, right? It's the location of this production.csv data that we have sitting in S3. And then the second one is the output location, which is going to be where we're going to be writing to as part of this workflow. So we can either manually enter this, or as I'm doing for this presentation, we're going to have an API that automatically populates it and kicks it off. And I'll show you guys how that's happening later. But first, let's run through this notebook real quick. So the first thing we're going to do is we're going to read in our training data. It's currently sitting as a CSV. We read it in to be a Spark data frame. We can take a look at it here. So the structure, nature, and purpose of this data is that it was taken from a news organization that has extracted some NLP features about news journal articles, as well as collected the number of shares that they've gotten. And we're going to try to use information that we have about the article at the time of its publication to know how many shares it'll get over the lifetime of the article. So we're going to use things like the number of words in the article, the average global sentiment, so like how positive or negative is it, the average length of the words in it, all of these things. I personally have a prediction that probably more negative or more divisive articles are going to be shared more often. We could try validating that as part of this exercise. So now that we understand the data, let's get into building our machine learning model. The first thing that we need to do, this data is already nice and clean for us, so the only data preparation that we have to do is really a quirk or an anomaly of Spark that we need to assemble our multiple columns of features into a single column feature which has a vector of all of those different independent variables. So don't worry too much about what's happening here. Basically, we're just compressing these multiple columns into a single column and renaming our label column from shares to label. Then we're using Spark ML to create a really simple linear regression, right? We're trying to predict the number of shares, which is a continuous variable. So yeah, so we're going to use linear regression to regress and predict against that. It takes only a few lines to build this linear regression in Spark ML, which is super convenient. Then we're going to be reading in our production data, right, from this location that was dynamically specified at the top of the notebook. You can see that it has the exact same structure as our previous data, with the only missing component being the number of shares, right? This is theoretically production data, so we don't know yet how many shares have been made. So we need to go through the same process as we did before, right? We need to pull out this feature column. We need to transform, so we need to actually do the inferencing and make the predictions based on our production data to create our final predictions. And then we're going to save our predictions back to our output location. And in order to cause this notebook to run through and have it happen automatically every day, which is what we want to do. At the end of every day, we want to predict how many shares every article that's been published that day will get. What we can do is we can use Airflow, which is an open source task orchestration engine, which was open sourced by Airbnb. Airflow is very convenient for data engineers because it allows you to specify your ETL pipeline as a directed acyclic graph with multiple nodes. In our case, we only have a single node, right? We're just going to be running this notebook with specified parameters. We can take a look at the code that's used to generate this DAG. It's really super simple and it's completely Pythonic. So the input location is just this static string, but the output location is the thing that's dynamically changing. So we're going to use string concatenation to create this bucket location that's going to be based on today's date. And then the rest of this is just Airflow specific stuff. You can see that we're using this Qubole operator to launch a Zeppelin notebook that's stored on Qubole. And we have this set to run, where's it set? We have it set to run daily. Yeah, there we go. We have it set to run daily. So this is going to run at the end of each day, and it's going to generate our predictions. So I cheated a little bit for the sake of this presentation because I didn't want to keep you guys here until midnight. And a few minutes ago, I pressed play to manually trigger this DAG. And if we take a look in the management console for S3, we can take a look at the predictions bucket. We can refresh it. Man, I was sweating for a second. I was like, where is it? But it's here. We can download it and just verify real quick that we have in fact made predictions. We're going to open it in Excel. Yeah, we can see that we have this nice column of predictions that have been saved back to S3 that now we can aggregate or send off to management. We can send it back to the authors to tell them this is how many shares we expect your article to get. The next useful step would be to tell them why we think it's going to get that way, right? Which is model interpretability, which I'll get to in a future presentation, not today.
Dang it.
Do you guys have any questions? Yeah, it's a lot of information all at once. Yeah.
I'm just curious, so are you guys running your own Spark cluster? Or are you sitting on top of Databricks? What is your company?
Definitely not. I can tell you for sure that we're not sitting on top of Databricks. So Qubole, I hesitate to say is a Databricks competitor because it implies that we do the same thing. We offer Spark as a service, just like Databricks does. We also offer Hadoop, Hive, Presto, and Airflow as services and provide a more integrated platform.
Right, you're putting all the pieces together instead of one.
Yeah,
Kind of.
exactly.
Okay.
Yeah.
So you're
But it's-
hosting, and managing this on all the cloud services?
Yes. Yeah.
Even Oracle.
Yeah, we sit on AWS, GCP, Azure, and Oracle Cloud, as Brandon is alluding to. They paid us some money.
Sorry for saying Databricks.
No. It's helpful to explain what it is that we do by saying what it is that we don't. Yeah. Any more questions? If you want to name some more of our competitors, I can explain the differences too. Really? Nothing from anybody? That was a lot of information. Yeah.
You said that you could, you had a hypothesis that said that more negative articles are going to be more shared.
Mhm.
So, and you said we could test that. So how would you test that?
And it's so sad.
Because the shares don't have any criteria at all in that spreadsheet. So it actually would be helpful if the output showed, like, if we could copy some data points to the output.
Totally. So that's the question that you're asking about, or the topic that you're asking about, is called model interpretability. And that's another issue that's recently academia has been getting more into, but has been a problem in industry for a really, really long time. And it's a presentation that I hope to give in a few months probably, because it's a really, really interesting topic. In this case, we picked a really simple model. We just picked a linear regression, which conveniently you can just look at the coefficients. And although with multiple linear regression, because of relationships between the independent variables, it's not going to be a perfect predictor. You can basically look at the magnitude of the coefficients in deciding which ones are most important in predicting the final result. So I actually output the coefficients here, and we can take a look at how these coefficients compare to the different elements. So let's take a look. What's the biggest number that we see here? I see a 3,500 and a 20,000. And the 20,000 is correlated with global negative rate of negative words. So the more negative words you have, the higher the number of shares.
Interesting.
I'm sorry, the higher the ratio of negative words to your overall article, which I feel like in our modern day and age makes a lot of sense, right? Yeah. Model interpretability is a really interesting question, and I really would like to talk about it for hours and hours and hours. And I will someday.
Good, practically speaking, so this model, what is it that's deployed, like integrated with, right? Like, is it, that's the next step on the like pipeline?
So this is an example of a deployment. It's a batch deployment, so we're not integrating it with an application, right? We could theoretically, if I had built, a fake news service app or something that like predicted for you, because you've written this article, this is how many shares we think you're going to get, right? We could do that as a real-time deployment. Alternatively, what we could do is we could run this at the end of every day based on all of the articles that have been published that day. And then the next morning, the analyst can print this out and hand it off to his boss or some executive and say, this is how many shares we expect to get on all of our different articles today. We think this one's going to get this many and that one's going to get that many. So yeah, so there's a lot of different ways that we could usefully deploy and productionize this model. Cool. If there's no more questions.
Okay, so how do you run? Is it, because you're integrating these other technologies and they're running on these different servers. And so how does your service, what's your business model, or what's the pricing structure? Or how do you
We can talk later. I mean, I don't want to like make it a sales pitch here in the.
Well, I guess just in general, is it some kind of a subscription model, or is it some kind of a software buy, or what? Software as a
You
service,
just pay for usage on
or just usage kind of thing?
Yeah, you pay for, it's credit based, so
Yeah.
it's over the top of whatever service you're using.
You pay for the.
But I swear this presentation's not about Qubole.
Hey, do you have a SageMaker example you're going to do now?
No, I don't. The integration is very, very simple. Like it's not even really worth showing an example of because it just requires clicking.
You just call them the API endpoint, you need the data back.
Exactly. Yeah. Yeah, I just decided to focus on the batch one because it's the easiest to explain while still having a little bit of meat on it. And because I think it nicely shows off different aspects of the Qubole product. Okay, in that case, please go enjoy more queso and chips and tacos.
And no more questions, that's it? I'm just kidding. I'm just
Do you,
kidding.
do you like Git version your notebooks or?
I don't personally, because I am a lazy data scientist. People who are really doing like production level stuff would have a GitHub integration. We have another way of doing version control, but there is a GitHub integration for Git scheduling. Yeah. I'm going to stop answering Qubole related questions because, yeah. But I will be happy to answer them after the presentation when we're not being recorded on Mariah's time.
This is not my time, it's your time. You're talking.
Well, anyway, so I'm happy to answer any questions about Qubole or machine learning or data science in general. If you guys have questions that are really applicable to the whole group, I'll answer them now. If you have questions that are more one-on-one, I'm happy to answer them afterwards.
Wait. I have a question.
Yeah.
Okay, so imagine, I know we're kind of talking, the SageMaker uses the APIs, which I think is wonderful. And it can be, and having used SageMaker for that instance, but I guess my question is, what do you prefer or have a recommendation as opposed to using the notebook on the back end as opposed to a script? I know there are both options in SageMaker, and I know from personal experience, the notebook instances tend to be very large. So I guess, which would you recommend? What case is what better? You know, what can you give insight into that use case? I would appreciate.
Okay, I'm going to give you a software engineering answer as opposed to a data science answer.
That's a good answer.
Because really productionization is an engineering issue, right? Like it's about turning something into something useful, which is engineering. And it's about integrating with an engineer-made application. So it's best to follow best engineering practices. In which case I would say, use the notebook for dev, use the refactor it as a single script for prod.
Sounds like the answer I'd give. Good.
Yeah.
Sorry, I didn't want to sound like I knew the answer to it. Because the ones I interfaced with were deployed notebooks, but it was also a very simple use case. But I feel like we end up we want our models to do things. So we want to use the CPU space or GPU space to do things, not to house a notebook. So, okay,
Yeah.
I'm glad that we agree. You validated your knowledge in my eyes.
That's all I ever wanted to. Yeah, I think that brings up a kind of interesting point, right? In that if you were just, okay, so what Mariah is referencing is that in SageMaker, you can either deploy your model as it's sitting in the way that you probably developed it, which is using a notebook interface, because that's what most data scientists are used to using when they're developing their models, or you can repackage it as a script, right? As just like a singly contained script, in which case it doesn't need all of the bulkiness of Jupyter in order to run. So if you're being lazy, right, if you're a data scientist, in other words, what you're probably going to want to do is just deploy it as the notebook. But if you're trying to really optimize, as Mariah wants to do, you need to put in that extra step, which is, although not really refactoring, is one step closer to the refactoring that we were trying to avoid in the first place. So all of these things exist more on a spectrum than as discrete points, but it's still a useful framework to think about these two dichotomies of the old way of doing it and new way of doing it, which was much more data scientist driven, much more reactive and quick and agile, and much more idempotent and microservice based. Yeah.
When you let go of all your data engineers, did they get jobs and find work like TaskRabbit or something like that? Just joking.
Qubole, to be clear, has never fired a data
I'm just
engineer.
kidding.
Yeah, I've been hearing that's been a thing in Utah lately. I think the really cool thing about the space that we're working in is that there's room in here for everybody, right? And like, we still need everybody. So all that this is doing is it's letting data engineers focus on the really interesting things that they want to be working on, right? Like, they probably don't want to be sitting there refactoring a model that somebody else built. They want to be thinking about what's the most efficient way to create a brand new pipeline so that I can get more data to my stakeholders, right? This lets them focus on the stuff that's interesting and valuable to them and let the data scientists muck around with the model that they've been developing. It's like when IDEs came out and people were like, oh, programmers are going to lose their jobs. Or like when autopilot on planes came out and people were like, pilots are going to lose their jobs. No, it made everybody more efficient, and that's better. So
Just give them more things to do.
yeah, also true. Okay, any other questions?
Sorry, was it Airflow?
Yep.
Airflow, is that like a replacement of cron jobs?
Yes.
Yeah, it's way better than Crunch.
It's not replacement, it's just forget cron jobs.
That looks great, so.
Yeah, it's really cool. And Matt, the person who said that, does not work for us, so.
Oh, I know. It's awesome.
Okay.
Change your life.
That is pretty dope.
Several talks on Airflow. I'll be speaking about Airflow at DevOps Days if you're going to DevOps
Oh,
Days.
that's cool.
No way.
Now I want to go to DevOps days.
It'll be a workshop. It'll be like a 2-hour thing. You'll stand it up and build some tags and stuff.
Man, pay for us to go to that workshop. We don't even need it.
It's an opportunity.
Take it out of your
Hey.
meetup budget.
We don't have a meetup. Anyway, that's it. We'll give you a real round of applause now.